Bismillahirrahmanirrahim. Hello everyone. I'm Dr. Mohsen from KFU IT Rahim Yar Khan. Today we are going to discuss remote sensing sensors, four dimensions of remote sensing. There are four dimensions of remote sensing by altitudes. Remote sensing can be divided into four stages or division based on altitude of the sensor. Ground observation approximately ranges 0 to 50 feet. Low altitude airplane less than 10,000 feet. High altitude airplane greater than 10,000 feet, and satellite greater than 150 miles. Advantage of ground level sensors: lowest per unit cost, can have a self-contained light source, ability to collect data at any time, potential for very high resolution data collection. Data can be easily georeferenced for use in GIS. Dis Disadvantage of ground level sensing are relatively high cost to scan large area unless part of another field operation. Cannot simultaneously scan the entire field. Active lighted sensor with GPS mounted on ATV is presented here in picture. 40 acre of wheat pasture center scanned with the ATV as shown previously in the previous slide. The pattern of scanning is presented here, and DBI points and their range is presented. Interpolated surface from ATV scan data. So, advantage of aerial remote sensing: can quickly scan large area. Cost per acre when scanning large areas is relatively low. Data can be collected at high resolution, less than 1 meter. User has some control over when data are collected. Disadvantage of aerial remote sensing is image must be rectified and georeferenced. Cost to scan small area is high. Data cannot be collected at night or in bad weather. Radiometric calibration must be performed on image for temporal comparison. 3-band digital camera and airplane is shown here to map the agriculture land and other area. And DVI of area at 1 meter resolution. Diagram is shown here. A level of detail presented here, that how much variation is in the fields at different scale. Advantage of satellite sensing: historical data are readily available. Cost per acre of large area image is very low. Very large area can be scanned nearly instantaneously. Data for radiometric bands up to 16 micrometer or 1600 nanometer are available. Disadvantages of satellite sensing include resolution can be lower than other sources, cannot control when an area is scanned. Landsat scan each area is scanned every 16 to 26 days. Correction of radiometric data is challenging because of atmospheric interference. Landsat satellite program was started United States NASA satellite. Images from Landsat NASA 4 through 8 available from USGS, South Dakota, Private Aconos, QuickBird, French Spot IRS. NASA imaging has been privatized. So here are the websites that can be used to download the Landsat data. NASA Landsat website, national website to download this data is also here from the NASA. Landsat satellite, Landsat scene, 185 kilometer into 185 kilometer. Quantization range is 12 bits. 16 days temporal resolution. Currently 2 satellites are operational, Landsat 7 and 8. The bandwidth of Landsat is presented here. Wavelength and the resolution. Coastal aerosols wavelength is 0.433 to 0.453 and resolution is 30 meter. Only the pan chromatic band has 15-meter resolution, while all other band has 30-meter resolution, while the wavelength variation is from 1.360 to 1.39 to 0.43 to 0.53 micrometer. Uh, so we will discuss about the sensors. Optical sensors. Most optical sensors are passive and can detect reflection and transmittance. Visible light range 0.4 to zero point 0.7 micrometer. Near infrared 0.7 to 1.3 micrometer. Short wave mid infrared 1.3 to 2.5 micrometer. Other systems include thermal sensors that detect amount of emitted heat 8 to 14 micrometer. Optical sensors optical systems are carried on airborne, satellite and ground-based platforms. Most optical systems are multispectral or hyperspectral. Satellite systems tend to have wide spectral band, whereas airborne systems use narrow spectral bands. Many multispectral optical systems also have a single high spatial resolution chromatic band. So here are the images. Other sensor types include LiDAR and radar. LiDAR is the light detection and ranging optical remote sensing using lasers, measuring distance to ground from airplane. Radar is the radio detection and ranging active microwave sensor, ranging or measuring the distance based on satellite, aerial and ground platform, can measure properties of the returning electromagnetic radiation, polarity, intensity and the phase. Useful for characterizing elevation, surface roughness and surface wetness. So here the electromagnetic spectrum is presented. Step to utilize remotely sensed data. Incorporate remote sensed and ground truth data into a GIS. Develop calibration equation for remote sensed data. Identify cause-effect relationship among measured variable and crop conditions. Treat regions and fields management zone based on the information generated. Thank you very much. If you have any question, you can ask me by commenting on this video on my YouTube channel, or the student of the class can ask me during the lecture on Google Meet. Thank you very much.